you've ever been in a meeting where someone said we need real-time data analytics, and then someone said, but we also need accurate historical data. And then everyone was just staring at each other, but the feeling was impossible to do. Yeah, welcome to the eternal struggle for data engineering. Today we are going to deep dive into Lambda and Kappa architecture, the two main approaches to solve the exact same problem. And yes, they are named after Greek letters because apparently we computer scientists peaked in college when we joined fraternities and never got over it. But here's the thing, understanding these architecture will literally change how you think about building data pipelines. So buckle up because we are going to architect the heck out of some data. Let's start first with the Lambda architecture. So Lambda architecture is used by data scientists and data engineers. Suppose you have a data ingestion system which is ingesting from lot of Kafka layers or lot of data ingestion pipeline. So let me make a multiple Kafka layers. In this case, we can just make again another one, and the data is being fed into our data ingestion system. Now what happens is this data ingestion system is used by multiple streams. From this ingested data, we have multiple players or multiple services who want to use this data. In case of analytics, we want to analyze the historical data. So we can use batch processing services, collect the data in a batches of maybe 1 hour or 24 hours, and then store it. So in this case, we can primarily use systems like Apache Spark. And with Apache Spark, they will be able to batch process the data on timelines which we put. This will be here. And after batching, we can use it to store it in a serving layer. Serving layer can be something like Hive or HDFS, where we can store the data. After it is fed into the serving layer, we can display it to multiple consumers using different types of dashboard like Grafana or another Kafka stream. So this way we can make it available for the different consumers. After this, there is another layer. We want to do a real-time processing. For this, we have a speed system. So speed system consumes data in real time. It is a time window data. In that, the time window can be from few seconds to few minutes. Here we use application like Apache Flink for real-time data ingestion. Once it is consumed by Apache Flink, it is shared with the output layer, that is Grafana or another Kafka. Similarly, the serving layer also can share it with the Grafana or output layer. This is how a typical Lambda process looks like. Now there is another variant which we can use. We can also use the same serving layer for the speed layer as well, where we can store the data in a Hive or an HDFS, and that way we can have a combined service layer for both of them. This is how a Lambda architecture works. Let me show you how the Kappa architecture works. So Kappa, as the name says, we'll have Kappa architecture, make it yellow, and we'll make the same ingestion layer, data ingestion. After making the ingestion layer, we can have multiple Kafka layers. We can make sure they are being pushed data into the ingestion layer. Here the difference is, instead of two layers, we will have one speed layer which will function for both batch layer and the speed layer for the real-time data ingestion. So we will have one speed layer in this case, which will have two functions. One is to the analytics based upon the batch frequency which we have set, and the real-time ingestion based upon the time frequency which we have done. And then the data is fed into the serving layer. After that, it is fed into the output layer. Let me draw the arrows, and this is how a typical Kappa architecture looks like. So this input layer can be any Kafka stream or log files, another ingestion layer. These can be data from multiple places, and then we serve it to the speed and the serving layer. Do you notice the difference? The difference is that we have single pipeline in Kappa architecture, whereas we have two different pipelines. If we want a separate system for analytics and another separate system for real-time data, we prefer to use Lambda architecture. But if we want a single layer and we want lesser accuracy, we primarily use Kappa architecture. Let's understand what are some of the real-world case studies. So for Lambda architecture, it is used by Netflix. Netflix uses batching for historical viewing pattern recommendation ratings. Then it uses the speed pipeline for real-time viewing stats, A/B test results. So with this, it is able to give personalized recommendation with real-time adjustment. LinkedIn uses batching for profile analytics and network graphs, whereas it uses Speedline for the real-time notification and messaging. Why we need this? Because we need accuracy for analytics and speed for engagement. For Kappa architecture, it is used by Uber because everything happens through event streams. The driver locations, the ride request, the pricing, replay of recalculations. And why do we need it? Because entire business model is real time. Spotify uses it for user listening events via Kafka. It adjusts the real-time playlist using the real-time streaming. And why we need it? Because we want to make sure that the music discovery needs to feel the instant. That is why Spotify uses Kappa. There are some other versions where different companies uses a hybrid version where they want to mix Lambda and Kappa architecture. Twitter or X, it uses real-time tweet ingestion then delivery. It uses batch processing for trends and analytics. It's kind of Lambda-ish but custom built. Why do we need it? Because timeline needs to be instant. Analytics can be slower. Amazon, different systems for different needs. Product catalog, it uses batching. Cart and checkout, it uses real-time. Recommendation, it uses hybrid. And why do we need it? Because right tool is needed for the right job. We cannot use mix and match. So did you notice a pattern? Big companies use whatever work for their specific needs. They're not religious about the architecture, but they are pragmatic about the problems. Why do we need Lambda architecture? So if you have two different systems, one for batching and one for streaming, you need perfect accuracy and perfect speed requirements. The complexity is high. In that case, if you can afford, you can use both of them. We need Kappa architecture if it is pure streaming, perfect real-time first. We can have a little bit up and down in the analytics and everything is event driven. In that case, we primarily use Kappa architecture. One important thing that I want to mention is Lambda architecture has nothing to do with AWS Lambda. It was just a coincidence that confuses thousands of developers every year. When AWS named their service, they just really liked the Greek letter. So somewhere in 2014, Nathan Marz was explaining his Lambda architecture and AWS was launching AWS Lambda and nobody at Amazon Googled to see if the name was taken. So the real lesson is even tech giants make mistakes in naming convention. So your architecture doesn't have to be perfect either. Alright, so that's about Lambda and Kappa architecture. If you made it this far, you know more about data architecture than most of the senior engineers there in the world. Hit like button if this video really helped you and comment if you've used Lambda or Kappa architecture or any other variant of this architecture. And guys, thank you for watching.
When they finally think you're wounded, then it's your chance to be ruthless.